My SD card's full. Try it again. So indistinguishable means you can't tell them apart. That's what that word means. So there is 4 letters that you're arranging. So 4 times 3 times 2 times 1, but this is 24, and that's too many. How many of those look the same? What do you think? Yeah, you can do that, yeah. So like if I wrote Emma, say that's the first M and the second M, and then I wrote the second M and then the first M, that's still the same arrangement. You can't tell the difference. And then maybe if I wrote M-E-M-A or M-E-M-A with the reverse, you can't tell them apart. So for every word that's a word, there's another one that's not. So it's 24 divided by what? 2, cut in half, because there was 2 M's that look the same, so we want to cut it in half. So that's 12 is the answer. So all of them we divided by 12, but there's actually a formula for that, and this looks like so here is the total. As if the items are all different. It doesn't have to be letters. It could be you're making arrangements of cupcakes, and all some of the cupcakes look the same, right? You're making a lineup for a window. You're putting them all in. How many ways can you arrange them? Well, the ones that look the same, whether you switch those or not, you wouldn't count that, right? So it could be anything. Cereal in an aisle at the grocery store, right? How many ways can you arrange a cereal? Well, the boxes that look the same, you don't really want to count those, okay? So the total is if all the items are different, and then these are divided by however many things are the same. In this one we only had 2 M's, so we divided by 2, which by the formula would be 2 factorial. But what's 2 factorial? 2 times 1? Just 2. Okay, so these are duplicate items. So for example, if we wanted to make arrangements of the letters in the word parallel. So there's more than just 2 letters that are the same. So the top is just how many letters there are. You pretend that they're all different. So how many letters are there? 4, 5, 6, 7, 8. And then these are the duplicates. So we need to divide out the duplicates. So there were 2 A's. So we would divide by 2. Just like the M's, or 2 factorial if we want to be technically correct. But it's still just 2. So that means every time we wrote one, we wrote another one with the L switched, it looked the same, so we don't want to count it. But what about the A switch? What about the L's? How many L's are there? 3 L's. So how many ways can you arrange 3 things? So they were all different. Well, you pick one for the first spot, one for out of 2 for the second spot. So there's 6 ways to arrange 3 items. So we need to divide by 6, which is 3 factorial. So these were for the 2 A's, and these were for the 3 L's. and then this would be your answer. And if you're putting that in your calculator, the 2 and the 3 are both divided, so you'd have to hit divided by both of them, or you could stick it in a bracket. But 8 factorial divided by 2 factorial divided by 3 factorial. 3360. So anything that looks the same, you divide that out, but factorial. Because if there was 4 things that look the same, there's like 24 ways you could arrange those 4, not just 4. So you don't divide just by 4, you divide by the factorial. Okay, so let's take a little break, and then we'll do the permutation combination examples after the break. Really the combinations, but we'll add ones that look like permutations. Okay. So I don't have a homework for you to do because you'll have to study, because on Tuesday is their test. And tomorrow I'll go in and cross off any questions you shouldn't do, because I've skipped a couple types, so I'll just cross off the ones that we didn't do. Because what I would normally do next, why this is 3 lectures, is the next, after I introduced all 3, we would do probability with them. But I'm just going to introduce them and not add probability back in. Okay. So get up, move around so you're not tired. Walk down the hall and back. For sure.
So if at least one item must be chosen, how many ways? So, wouldn't it technically not be subtracting one? Like, wouldn't it be like, okay, if you have to choose one, so wouldn't that make this 4 and 7 and 11?
Sure, and then add 5 times 6 times, that'll give you the same answer.
Like, and then...
So that's
and
with...
then 5 times 6
right.
times 11, and then...
Right.
5 times 7 times 10?
Right, if you add all those, you'll get 384.
Okay. So why do you add them all?
Well, because there's this many ways to pick a paper, and maybe none of these. Right, these are all the possibilities. So this one you're picking a paper for sure, this one you're picking a ribbon for sure, and this one you're picking, oh no, sorry. This one you're picking
sorry, I didn't put them,
yeah, card, ribbon, paper, right?
Yeah.
So they're all the options. These are the other ones, you can pick them or not pick them.
Okay.
So if you add up all of these, you should get 384.
Okay.
Which is a fine way to do it.
Okay.
I put them all in, even the none, and then just subtracted off the one that's none.
It's easier, yeah, I was just trying to...
But you don't have to do that. And on the test, you may not think of the shortest way to do something.
Right.
You might do
try and
the
reason it out, yeah.
Right, you might do the longer way, and that's fine, you'll get the right answer.
Okay.
Yeah.
Alright, I'll give you this here.
Actually, I need to take a bus to go back home.
Okay.
And the bus will leave at 8:46.
Okay.
Can I leave?
Oh, yeah, for sure.